Alright, you're welcome once again to Chesed Maths Clinic. We are going to be pinpointing a question under differentiation. Now, differentiation happens to be one of the topics that have been given to students and professionals and those that are into business mathematics a little bit of issues in terms of having the knowledge of differentiation. Don't forget, when we talk about differentiation, it's a topic under calculus that deals with continuous function, that is, we differentiate continuously. Question says solve y equals to 3x to the power of 3 minus 5x to the power of 2 plus 2x minus 7. Now, how do we solve this question? We will be guided by what we call the power, or applying the power law of differentiation. So what does that state? For us to solve this, we apply that knowledge, which is if we want to differentiate with respect to x, that's we differentiate the function y with respect to x, it is the same thing as n to the power of nx to the power of what? N minus 1. So if we have this nx to the power of n minus 1, it simply means that if the power here is whatever number, we subtract 1 from it and we multiply it by the x. This can be referred to as what we call case 1. Let's call this case 1. Now, we can also apply the knowledge of differentiation in a different form. When we want to differentiate the first derivative, we can use this, what we call the y over the x, as we differentiate the function with respect to x, and we apply this, we call it a nx to the power of n minus 1. This can be called case 2. So what do we mean in case 2? This a here simply means that if the a is a coefficient of this x, we multiply the power n by a and we subtract 1 from the power. So if we have a different coefficient, here in this case, the coefficient of x here is 1. That is why we have n here. So now let us consider these two cases in solving this particular problem. Now we are asked to differentiate this twice. We want to differentiate this function twice. So we pick it one after the other. So we want to differentiate the y over the x, which is equals to, we want to differentiate this. We are going to have what? By this law, or this law, we take 3 times 3. This 3 here can be referred to as the a here. So we take it to be what? 3 times what? 3x to the power of what? 3 minus 1. That is for the first function, for this. Okay, so 3 times 3 is what? 9. Then this x, 3 minus 1 is what? We have 2. Okay, so that's for the first one. And then for the second one, we differentiate again. The function dy with respect to x will be, for this one, we have minus what? 5 times the power, which is 2, x to the power of that 2 minus 1. So which will give us what? Minus 5 times 2 is what? Minus 10. Then x to the power of what? 2 minus 1 is 1. It's not necessarily we write power 1 here by law of indices. We already know that this is the same as power 1. So let's take for the next one. We take for the next one, we have the function dy with respect to the x is equal to, we differentiate that, we are going to have, the power here is 1. So it will be what? 1 times 2x to the power of that 1 minus 1, divided by this and this. So this is equal to what? 1 times 2 is 2x to the power of what? 1 minus 1 is 0. And this is the same thing as what? X to the power of 0 is 1. So 1 times 1, 2 times 1, sorry, is what? 2. 2 times 1 is 2. Now we have the first derivative for each of them. We have the first derivative, then let's differentiate a constant. if we are differentiating any constant, whether positive or negative, it is always equals to 0. So if we differentiate a constant, the y over the x, it will be what? Minus 7 is the same thing as 0. Why? Because the derivative of a constant is 0. Okay. So next we are going to see how we can solve the second derivative of this function. But before we solve the second derivative, we have to bring all these terms together. We have to bring this term, this term, this term, and this term together. Then we now differentiate it again, which will be the second derivative. So now we have differentiated the first derivative of the function. Now let us bring the first derivative of the function together. So this simply means that we are going to have the y of the function with respect to x, the x will be equal to, we have 9x squared, then minus 10x, then plus 2. Then the other one is plus 0. And it does not change. This is still the same thing as the y over the x is equal to 9x squared minus 10x plus 2. This 0 can go off. Now we take the second derivative. This is the first derivative. So by the formula for second derivative, if you are differentiating the second time, it will be d square y over the x squared. So it means we are picking for each terms here to differentiate them the second time. So let's pick for the first term, which will be, by the formula, it will be 2 times 9x to the power 2 minus 1. And this is the same as 2 times 9 is 18, x 2 minus 1 is 1. So like as I initially stated, we must not write the power 1 here because of the law of indices. So we already know this is power 1. Now let's differentiate the second time for the middle term, minus 10x. So the square y over the x squared is the same thing as differentiating this the second time. So how do we differentiate this? The power here is 1, don't forget. So it is the same thing as minus 10 times 1x to the power 1 minus 1. So this is equals to minus 10 times 1 is minus 10. Then x to the power of what? 1 minus 1 is 0. And this is also the same thing as x to the power of 0 is 1. So minus 10 times 1 gives us minus 10. And also, like as I earlier mentioned in the first derivative, if we want to differentiate a constant, whether positive or negative, it is always equals to 0. So if I take the second derivative, the square y over the x squared for 2, it is always equals to 0. So now we bring the terminologies together, the terms together. So this simply means that the square y over the x squared is equal to what? 18x minus 10 plus 0. And it is also the same as what? The square y over the x squared equal to 18x minus 10. Because this 0 is nothing. So with this knowledge, you can be able to continue differentiating, and as like I said, it is called a continuous differentiation. When we talk about calculus, it is a continuous differentiation. So you just like, share, and subscribe. If you have any questions, you can always drop it at the comment section so that we discuss more again. Bye bye.